so far, questions in this section where we've been interested in looking at a derivative and trying to find an original function are actually very special cases of what we refer to as differential equations. Some of you might recognize that name because that's a course in mathematics that many of you may take in maybe either your sophomore or junior year. Now, an equation which includes a function and its derivatives is what we call a differential equation. So you can take a look here. I could be asking the question, what function can I take the second derivative of, add 3 of its first derivatives to, add on its original formula, and generate x? What formula does that? I don't know. That's a tough question. What function could you take the second derivative of, the first derivative of, and no derivatives of, add them together in this way, and produce the value x? Now, there's also things like this. What function can I take the derivative of that turns into 4 times itself? Or what function can I take the derivative of that generates 6x plus 2? All of these, again, are differential equations, and we, in this class, are going to be specifically dealing with things that are more of this kind of latter form, where you'll notice that we're really going to just be given a derivative has this formula, but there's no y's in our formulas here. However, this sort of these other sorts of questions where multiple derivatives occur or the value of y occurs within that formula as well is very, very important in a course of differential equations, and we use this concept of differential equations to understand numerical estimates, to understand graphs of functions, different rates of change, and a whole bunch of different ideas that will be discussed more in detail in a differential equations course. So when we take a look at something like example 6, and we're asked, find a function f, if it's the case that the derivative of f is equal to this, and f of 0 is equal to -2, I know that I'm given here ultimately what we would consider a differential equation, although it's also what we would consider an initial value problem, since again I was given some initial value of the function. Now I'm going to ask you to actually go ahead and see if you can try to work through example 6 on your own. Now, at the beginning, you might recognize that this looks a little intimidating, or at least the second term does. So my advice to you would be to try to use a little bit of algebra before you go ahead and actually attempt to find an antiderivative here. So go ahead and pause the video, see if you can try to work through this particular question, and then when you unpause the video, you'll see me work through the solution. All right, so hopefully you actually did go ahead and try this out. Let's see what we would have. So first I'm going to go ahead and just quickly do some algebra here to make things a little bit nicer. I'm going to see that I could rewrite the second term here of my derivative as 20 over 1 plus x squared. Or if I wanted to, I could even write this 20 over on the side, and I could have 20 times 1 over 1 plus x squared. Now the reason that I do that is because now I can easily compute that my function of regular f would just be e to the x plus, and over here I recognize this now as a nice derivative rule. That's 20 times the inverse tangent of x. This is the derivative of 20 inverse tangent x. Now, of course, to make this as general as possible, I would have to put in a plus c. And now I need to find that value of plus c using my initial condition. So I would go ahead and state that if it's the case that f of 0 is equal to -2, then it must be that -2 is equal to e to the 0 plus 20 times the inverse tangent of 0 plus c. Now e to the 0 is just the value of 1. Inverse tangent of 0 is just 0, and so I'm going to end up with here that -3 should be equal to the value of c. And so I have everything that I need then to write out what f of x actually is. F of x here would be e to the x plus 20 times the inverse tangent of x minus 3. Hopefully you were able to get the exact same thing.